In this video, we're going to look at the graph of f of x equals sine of x, and we're going to start thinking about what the derivative to that function might be. So I'll show you the picture of sine x, but I want you to be careful about this scale because, as it says here, the diagram does not have boxes that are 1 by 1. In fact, they're approximately 1.57 by 1. Because the horizontal scale of the grid is pi over 2 units, okay, because we're dealing with trig functions. Okay, so the first step is to sketch an accurate tangent line to the graph at a whole bunch of points here. So let's go and do that first. So here is a graph of sine x, and at each of these points, let us graph a straight line, a tangent line. Maybe I can even do that using the shape tool. Let's see. So at negative 2 pi, yeah, sure, that works. Okay, so at negative 2 pi, that's not exact. It actually should be more like this. There you go. Can I move that down? Nope, can't move that down. That's okay. And then at negative 3 pi over 2, the tangent line will look like that. At negative pi, the tangent line will look approximately like that. At negative pi over 2, we have again a horizontal line. At 0, we have this diagonal line. That one's not quite right. Let's try again. That's a little better. At pi over 2, looks to be horizontal. At pi, we have this diagonal with a negative slope, 3 pi over 2, and then finally at 2 pi. Okay. Now at each of these lines, we're going to try to estimate the slope just by looking at the grid. So the easiest places are where the slope appears to be 0, right? These horizontal lines here, 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 here. We can estimate the slope to be 0, which means the derivative should be 0 at that point. So that's at negative 3 pi over 2, at negative pi over 2, at positive pi over 2, and at positive 3 pi over 2. Okay. What will be a little more challenging is trying to estimate the slope of these diagonal lines. But we can see all three of those lines look to have about the same slope. So let's zoom in to this one in the middle here. And let me try, if I can, to actually extend that line. That looks pretty good. Okay. So remember, this is pi over 2, about 1.57. And what's happening here, so if this is 1.57, this value, that's about 2/3 of the way, will be approximately 1. So this slope looks to be about equal to 1. We go up 1 and we go forward 1. Okay, so it might not be exactly correct. I mean, I know that it is, but it might not be. But it's approximately 1. So that will be at 0, at negative 2 pi, and at positive 2 pi. Now, the negative sloping lines here, the tangents here and here, seem to be about perpendicular to these lines that have a slope of 1, right? They seem to be about perpendicular to those. And so you can do a similar process, but because they're perpendicular, we'll say that that slope is about negative 1, right? If it's perpendicular, when we multiply the slopes, we should get negative 1. So we'll put negative 1 there at negative pi and at pi. And now, if we go to connect these, let's use a different color, and we sort of try to smooth it out, we get that the derivative kind of looks like this, right? Which kind of looks like sine, except it's not sine, right? It's sine that has been shifted because sine of 0, just like over here, should be 0. This function, when we plug in 0, we get 1. So this, in fact, looks a lot like cosine. And let me show you in Desmos one more thing. So in Desmos, if we think about the definition of the derivative, we think about taking sine of x plus h, where h is approaching 0, minus sine of x over h. In this case, I know h is approaching 0. I'm going to take h to be really small, 0.001. And again, when I graph it, this sure looks a lot like cosine. It's not exact, because this value is not equal to cosine. But if I were to take these numbers smaller and smaller, oops, let me add in an extra 0, it will converge to cosine. It will look more and more like cosine. Okay, so I just wanted to show you that as an alternate. And the conclusion that we should come to is that if we have the function f of x equals sine of x, then the derivative of that function f prime of x equals cosine x.